Hello everyone, I am teacher Wang Xing. Today, let's learn air pollution control technology together. Chapter 9, Section 1. The definition of VOCs and its emission sources and prevention. In this lesson, we will start with the definition and emission sources, vapor pressure and evaporation. Learn from three aspects of VOCs pollution prevention. Over the past 30 years of reform and opening up, China's economy has achieved rapid development. However, many environmental issues also come with it. The types of pollutants are also increasing. Volatile organic pollutants. It is a type of stimulating substance, teratogenic, carcinogenic, sudden and mutagenic effects, flammable and explosive organic matter, a great threat to human and ecosystem health. So what exactly is VOCs? Today, let's learn the definition and emission sources of VOCs together. Firstly, the definition of VOCs. For VOCs, there is no unified definition internationally. World Health Organization. The definition of total volatile organic compounds is melting point below room temperature, and the boiling point is between 50 to 260 degrees Celsius. General term for volatile organic compounds. The National Environmental Protection Agency defines it as carbon monoxide removal, other than carbonates, metal carbides, or carbonates. Anyone who can participate in the atmosphere. Carbonaceous compounds in photochemical reactions. EU Country Emission Cap Order 200-1/81/EC defines it as a. Under the action of sunlight, it can interact with nitrogen oxides, reactive, any human or natural source, organic compounds emitted. In our country, different fields also have different concepts regarding this. For example, the refining and petrochemical industries. Definition of air pollutant emission standards, VOCs at 20 degrees Celsius. Vapor pressure greater than or equal to 0.01 kilopascals, or under specific applicable conditions, having corresponding volatility. A collective term for all organic compounds. Technical requirements for environmental labeling products. The pesticide aerosol specifies that VOCs is at 101.3 kilopascals. Acetone removal. Ethyl acetate, 1,1,1,2 tetrafluoroethane, 1,1-difluoroethane, etc. Organic compounds with boiling points below 216 degrees Celsius. Technical requirements for environmental labeling products. The water-based coating will be applied at a pressure of 101.3 kilopascals. Any boiling point. Organic compounds below or equal to 250 degrees Celsius. Defined as VOCs. In this course, we will adopt a physical level definition, including those who are not lively, not participating in atmospheric photochemical oxidation reactions. Volatile organic compounds. The following are commonly used professional terms for volatile organic compounds. Now let's learn about the impact of VOCs together. The main hazards of volatile organic compounds are in three aspects: hazards to the atmospheric environment, hazards of ambient air, hazards to human and animal health. Common haze in recent years. Because volatile organic compounds enter the atmospheric environment, and a certain degree of harm to human health. VOCs in the atmospheric environment undergo photochemical reactions, formation of photochemical oxides such as ozone, impact on environmental atmospheric quality, and ecological balance, all have serious impacts. Solid and liquid VOCs emissions can directly form PM2.5. VOCs emitted in gaseous form. After the atmospheric environment cools down, formation of condensable particles, most of them are also PM2.5. VOCs emissions cause most PM2.5 pollution. Some volatile VOCs are toxic or foul-smelling through respiratory penetration, etc. Physiological and psychological effects on the human body will have a certain impact. Now let's learn together. Emissions and sources of VOCs. There are two types of emissions from VOCs: natural sources and anthropogenic sources. The former has a global emission of approximately 1,200 mt. The main representative substance is foreign material diene, alpha-pinene, white tower pinene, olefin, and other plants. Ecological functional emissions. basically uncontrollable sources. The latter mainly originates from human production and life, incomplete combustion process, and the process of volatilization and spillage involving organic products. Its chemical components are extremely rich. The following table shows China in 2007. In 2011, 27 countries from the United States and the European Union, the main anthropogenic emission sources of VOCs, and its emission estimation. From the table, it can be seen that transportation and solvent use are common sources of focus, about half of the total emissions, among them road motor vehicle emissions, approximately accounting for over 80% of the total emissions from mobile sources of transportation, and the processes of coating spraying and ink printing. It is also an important source of emissions, approximately 50% of the total emissions from solvent use. In addition, fixed combustion sources and waste treatment in China, relatively high emissions from disposal sources. It mainly comes from biomass in rural areas, home stove burning, two major activities, namely field burning of agricultural straw waste. Behavior. Compared to natural sources, VOCs has low anthropogenic emissions from sources, only a few percent, but due to the road, motor vehicles and various industrial activities, highly concentrated in urban areas, VOCs that cause anthropogenic emissions become important pollutants affecting regional air quality. VOCs emitted by humans contains a certain amount of benzene, toxic chemical components such as xylene, N-hexane, and formaldehyde, threatening human health and safety. Therefore, the control technology of anthropogenic VOCs, widely concerned by research and market sectors. Let's learn about vapor pressure and evaporation together. 1. Vapor pressure. Vapor pressure is used to determine organic matter, the main basis for whether it belongs to volatile organic compounds. The vapor pressure of a liquid or solid substance, temperature dependent. The higher the temperature, the higher the vapor pressure. The content of VOCs in the air is low, can be regarded as an ideal gas. Usable Raldine, estimating the content of VOCs in mixed gases by law. The following is the formula for Raoult's law. In order to calculate the correlation between gas-liquid equilibrium system, most in thermodynamics, usually, the Clausius-Clapeyron equation is used. The following is the main expression of the Paylong equation. Okay. Let's learn the comparison between volatilization and dissolution dates together. In application, most organic matter, all placed in containers that are connected to the atmosphere. Therefore, liquefaction is prone to occur. Pollution caused by entering the atmospheric environment. Some organic compounds such as ethane, propane, and butane. The vapor pressure at room temperature is greater than atmospheric pressure. It will boil violently. Therefore, such substances must be stored under pressure and sealed. Organic matter used as fuel, such as gasoline, liquefied gas, etc., during loading, unloading, and transportation, will emit a large amount of VOCs due to volatilization, intensify pollution of the atmospheric environment. In the emissions of VOCs in the United States, 80% from solvent use. During transportation and VOC storage, most VOCs are slightly soluble in water. It can be achieved through simple phase separation and propylene method. Remove some VOCs, but due to the removal of VOCs from the water, still contains a small amount of soluble hydrocarbons. Therefore, further processing is necessary. Only then can it be discharged into the municipal drainage network or receiving water body. Due to the presence of hydrocarbons in acute VOCs, it also contains nitrogen and oxygen elements. Non-polar VOCs containing only hydrocarbons, more soluble in water. Differences in solubility make the polarity VOCs in the gas easier to remove through washing, but VOCs dissolved in water are more difficult to remove. At the same molecular weight, solubility of polar organic compounds, more than 100 times that of non-polar organic matter. In the same group of organic compounds, solubility decreases with increasing molecular weight. Finally, let's learn about VOCs pollution prevention and oxidation together. VOCs control technology can be divided into two categories: preventive measures focused on preventing leakage, replacing raw materials, changing operating conditions, replacing equipment, etc., and control measures mainly focused on unfinished governance. Firstly, the replacement of VOCs, using low toxicity or non-toxic raw materials, replacing or partially replacing organic solvents with raw materials, ensure no or minimal discharge of harmful VOCs, is an effective way to reduce such pollution. From oily paint coatings and inks to water-based paint coatings, the transformation of ink significantly reduces VOCs emissions, but due to water-based paint, poor quality of coatings and inks, restricting their use, substitution usually only reduces and cannot completely eliminate the emissions of VOCs. Introducing compressed natural gas, liquefied petroleum gas or propane, replacing gasoline as engine fuel, another alternative form of reducing VOCs emissions. Because compressed gas fuel is being produced for compression metering, during combustion, less VOCs emissions generated than gasoline. To reduce VOCs emissions, oil quality should also be improved. Cancel low-octane gasoline, improving the combustion performance of gasoline. 2. Process reform, replacing volatile solvent processes with non-volatile solvent processes. UV lithography for curing bed powder coating box, petroleum-grade petrochemical production process, recycling and utilization of vent gas. 3. Leakage loss and control, loss of breathing and emptying during first filling, operational loss, when VOC solution is filled into the container, or when exporting from a container, due to changes in temperature and air pressure, VOC gas overflow. VOC emissions caused by breathing and emptying can be calculated as follows. Respiratory loss, temperature variation, causes the container to inhale and exhale, resulting in organic matter loss. Exhale during the day, inhalation at night. Respiratory filling and emptying losses can be achieved by attaching a vacuum pressure valve at the outlet of the container, also known as steam protection valve to control. When the pressure difference passing through is small, the valve is closed. When rushing in, when emptying, or there is a significant change in temperature and pressure, causing significant steam outflow and inflow, the valve will automatically open. Transfer of gasoline and respiratory loss. Volatilization of VOCs mainly depends on vapor pressure and molecular weight of organic substances. For pure components, such as benzene, molecular weight is a constant. Vapor pressure is a simple function of temperature. For VOC mixtures such as gasoline, during the gasification of liquid organic matter, changes in vapor pressure and molecular weight of steam. Volatility is a function of temperature, molecular weight, and vapor pressure. Classmates, through the learning of this lesson, basic understanding of the definition and emission sources of VOCs, vapor pressure and evaporation, basic measures for VOC pollution prevention. That's all for today's class. Thank you.